You are tuned to Iri-e-learning and I am your host, Teacher. In this small concept lesson, we will practice calculating percentage composition by mass. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to calculate the percentage composition by mass. We have a single learning objective, so we'll get straight to it by calculating the percentage composition by mass of different elements within a compound. To find the percentage composition of an element within a compound, we will use the following equation, where the percentage composition is equal to the ratio of the mass of the element divided by the total mass of the compound. The ratio of the masses is then multiplied by 100 to express the answer as a percentage. Note that the mass used in the equation can either be the relative mass or the molar mass. So if you're going to use the relative mass for the element, then you use the relative mass for the compound. If you're going to use the molar mass for the element, then you use the molar mass of the compound. Example 1. Find the percentage composition of each element in sodium carbonate. The chemical formula for sodium carbonate is Na2CO3. Ensure that you review Lesson 2 of this unit, Calculating Molecular Mass and Relative Mass, before you proceed with this lesson. Before calculating the percentage composition of elements within a compound, we must first calculate the molar mass or relative mass of the compound. For example, we will calculate the relative formula mass for sodium carbonate as we have it here. We are saying relative formula mass because sodium carbonate is an ionic compound. Sodium carbonate consists of 2 sodium atoms, 1 carbon atom, and 3 oxygen atoms. Using the relative atomic masses of the elements, we can now find the relative formula mass for sodium carbonate. So as per usual, we will find the relative mass for each element within the compound. So for sodium, relative mass 23 multiplied by 2 sodium atoms will give a product of 46. For carbon, a relative mass of 12 multiplied by 1 carbon atom gives the relative mass for carbon within the compound as 12. And then for oxygen, the relative mass of oxygen 16 multiplied by 3 oxygen atoms give the relative mass for oxygen within the compound as 48. Then the total relative mass of sodium carbonate works out to be 106. We can now find the percentage composition of each element within sodium carbonate. Starting with sodium, we need to know the total mass of sodium within the sodium carbonate. If you recall, the total relative mass of the element sodium is 46 out of the total relative mass of 106 for sodium carbonate. Therefore, we have the relative mass of 46 for sodium divided by 106 multiplied by 100, and we get 43.4% sodium within sodium carbonate. Next, we find the percentage composition of carbon within sodium carbonate. Recall that the total relative mass of carbon within sodium carbonate is 12, and the total relative mass of sodium carbonate is 106. Therefore, we have 12 divided by 106 multiplied by 100, which gives 11.3% carbon within sodium carbonate. Next, for oxygen, recall that the total relative mass of oxygen within the compound is 48, and the total compound is 106. Therefore, the percentage composition of oxygen becomes 48 divided by 106 multiplied by 100, which gives percentage composition of 45.3% for oxygen. If we are finding the percentage composition of all the elements within a compound, just note that the total percent should be 100%. So when we add all the percentage compositions of the elements within the compound, our final result should be 100%. Example 2, find the percentage composition of the ammonium and sulfate radicals within ammonium sulfate. So in this example, we don't want the percentage composition for individual elements. What we want is a percentage composition for the polyatomic ions, also called radicals, within the compound. So we are required to find the percentage composition for the ammonium ion and the sulfate ion. And note that there are 2 ammonium ions within the ammonium sulfate compound, but only 1 sulfate radical. So to find the percentage composition of the different radicals, we're going to find the relative mass of each element within the compound and the total relative mass of the ammonium sulfate compound. So we use the relative masses or the mass numbers on the extracts from our periodic table here to assist us with the calculation. So we see that there are 2 nitrogens, because anything in brackets will be multiplied by that subscript number. So we have 1 nitrogen times 2, so that's 2 nitrogens. 4 times 2 is 8 hydrogens. There's 1 sulfur and 4 oxygens. So the relative mass of nitrogen is 14 times 2 nitrogen atoms, which gives a total relative mass for nitrogen of 28. Hydrogen, relative mass of 1 times 8 hydrogens, giving a total product of 8 for hydrogen. Then for sulfur, relative mass 32 times 1 sulfur gives a total relative mass of 32 for sulfur. And for oxygen, relative mass 16 times 4 oxygen atoms, giving a total of 64 for the relative mass of oxygen within the compound. So the total relative mass of the ammonium sulfate is 132. However, remember we are required not to find the percentage composition of the individual elements, but of the radicals or the ions within the compound. So we have the ammonium ion, which comprises of the nitrogens and the hydrogens together. So if we are to find the total of 28 plus 8, which comprises of all the nitrogen and hydrogen within the compound, that gives us a total relative mass of 36 for the ammonium radical or ion. Then for the sulfate radical, comprised of the sulfur and the oxygen atoms, we have 32 plus 64, which gives a total relative mass for the sulfate ions as 96. So now we know that the ammonium ion occupies 36 out of 132 of the compound relative mass, while the sulfate ion has a relative mass of 96 out of the total 132 for the compound. So we can now go ahead and find the percentage composition for the ammonium ion and the sulfate ion. So for the ammonium ion, we saw that was 36 divided by 132 multiplied by 100, which gives the percentage composition of the ammonium ion to be 27.3. For the sulfate ion, it will be 96 divided by 132 multiplied by 100, which gives the percentage composition for the sulfate as 72.7%. Since this comprises all the ions within the compound ammonium sulfate, the percentage composition of both should add to give 100%. And our final example, find the percentage composition of each element in 1 molecule of glucose. The chemical formula for glucose is C6H12O6. And as per usual, we find the relative mass of each element within the compound and the total relative mass of the compound. As we can see from the chemical formula of glucose, there are 6 carbons, 12 hydrogens, and 6 oxygen atoms. We multiply the quantity of each element by its mass number or its relative atomic mass. Then we end up with a total relative mass of carbon as 72, and that of hydrogen as 12, and that of oxygen as 96, giving a total relative mass of 180. We can go ahead and find the percentage composition for each element within glucose. The percentage composition of carbon would be 72 divided by 180 multiplied by 100, which gives percentage composition of 40% for carbon. The percentage composition for hydrogen would be 12 divided by 180 multiplied by 100, which is 6.7%. Then the percentage composition for oxygen would be 96 divided by 180 multiplied by 100, giving the percentage composition as 53.3%. Since the percentage composition for each element was found, the total percent composition should add up to give 100%. And now for the lesson summary point. The percentage composition is equal to the mass of the element or the ion divided by the total mass of the compound multiplied by 100. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. The composition of calcium in calcium oxide is 71%. What is the percentage composition of oxygen? A. 39%, B. 16%, C. 40%, D. 29%. The answer is D. 29%. How did we arrive at that answer? Calcium oxide consists of calcium and oxygen. The total percent composition for the compound is 100%, of which 71% is calcium. Therefore, if we want to find the percent of oxygen, we subtract 71% from the total composition of 100, and that gives us 29%. Question 2. What is the percentage composition of sodium in sodium chloride if the relative atomic mass of sodium is 23 and the relative formula mass of sodium chloride is 58.5? A. 35.5%, B. 39.3%, C. 23%, D. 60.7%. The answer is B. 39.3%. How did we arrive at this answer? We know that the percentage composition of sodium would be the relative mass of sodium, which is 23, divided by the total mass of the compound, sodium chloride, which is 58.5%, multiplied by 100, which gives 39.3%. Question 3. X2O3 is a metal oxide with a molar mass of 102 grams per mole. If oxygen has a total molar mass of 48 grams per mole, what is the percentage composition of X? A. 53%, B. 47%, C. 35%, D. None of these. The answer is A, 53%. We arrive at this answer using the following solution. So first we find the percentage of oxygen, where 48 grams per mole is divided by 102 grams per mole. We don't have the units because they actually cancel each other, and multiply that by 100 to give 47%. So now that we know that of the entire compound, oxygen, the 3 oxygen atoms have a total composition of 47%. Therefore, to find the percentage of X, we subtract the total percentage composition of oxygen from 100%, which is for the compound, and we end up with 53%. A second method is to first find the molar mass of X by subtracting the total molar mass of oxygen, which is 48, from that of the compound, which is 102, and that gives a molar mass of 54 grams per mole. We then find the percentage composition of X by dividing the molar mass of X by the total molar mass of the metal oxide, multiplying by 100, and that gives us 53%. Question 4. What is the percentage composition of carbon and oxygen in carbon dioxide? Use the periodic table information provided to assist with your calculations. A. Carbon 73%, oxygen 27%. B. Carbon 43%, oxygen 27%. C. Carbon 27%, oxygen 73%. D. Carbon 77%, oxygen 23%. The answer is C, where the percentage composition of carbon is 27 and that of oxygen is 73 within carbon dioxide. How did we arrive at the answer? First, we find the relative mass for carbon dioxide. As you can see, the relative mass for carbon is 12 and that for oxygen is 32, and the relative mass for carbon dioxide is 44. Therefore, the percentage composition of carbon is 12 divided by 44 multiplied by 100, which is 27, and the percentage composition of oxygen is 32 divided by 44 multiplied by 100, which is 73%. Question 5. What is the percentage composition of hydrogen in ethanol? Use the periodic table information to assist with your calculation. A. 52%, B. 13%, C. 35%, D. 11%. The answer is B. 13%. First, we find the relative mass for ethanol as follows. Then we will find the percentage composition of hydrogen by noting the relative mass of hydrogen in the compound, which is 6 divided by the total relative mass of ethanol, which is 46 multiplied by 100, and that gives 13%. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.